folks, welcome back to another video. Today we're looking at question 792, number of matching subsequences. The way we'll be approaching this problem is by using a hash map, which maps to the number of words. So it's a character versus the number of words that start with that particular character. So let's walk through an example. So given the input S, which is A, B, C, D, E, and the words are A, B, B, A, C, D, and A, C, E, the first thing that we will be doing is creating a hash map with the key as each and every single character starting from A all the way to Z. And you could optimize that possibly by just creating it for all the letters in S. But we will be creating that, and we will be adding all of the words to that particular hash map. So what does that look like? So for the hash map with the key A, you will have A, C, D, and A, E, because they all start with the same letter. And for BB will be added to the list B. So that would be step 0 before we actually loop through all of the words again. And then step 1 would be you'll take the first character, so you'll be iterating with every single character in the input word that's given to you. So since the character is A, you will go to the map and look at all of the words in A, right? So you have A, C, D, and A, E, and then you will remove the first letter of each, the first letter, since we already came across A, and you'll be adding whatever is left back to the map. So since A doesn't really have anything else, we increment the count as 1. So this will be the result. So at this point, the count will be 1. We have CD. C will be assigned. CD will be assigned to CD, and a CE will be assigned to CE. So what have we done here? The thing that we've done is that the first letter that we see in S, we take that, we get all of the words in that particular bucket from the hash map, and we remove that first letter and add the rest of the word to the corresponding starting letter. So in our case, it would be CD and AE. And since A is only one letter and it doesn't have any other subsequent letters, you increment the count by 1. That means we have actually found the entire subsequence for that particular letter. And then we iterate through the second letter, which is B. And since we have B and B, you just remove the first letter and add it back to B, since we need to finish another letter to actually count that as a subsequence, and everything else stays the same. The count is still at 1, which is the result that we'll be returning in the end. So the next letter that we have in the word is C. So you look at all of the words in C, which you have C, D, and CE. You will remove the letter C, and you'll be adding the remaining word back to the hash map. So you have D, you'll add D right here, and then you have E, you add E right here, and the count still remains 1. And then you iterate through the next letter in the input, which is D. And then since D, you only have a single letter D here, you increment the count to 2. So at this point, your result will be 2, and then you do that for the last letter as well, which is E. And since E is just a single letter, you increment the count to 3, and that's what you'd be returning, which is the answer right here. So I hope that walking through that example helped. So let's walk through the code itself. So the first thing that we need is a hash map, as I mentioned before. So it will be a character matching to a Q. Yeah. So, and then the Q will hold strings, and then let's call it map, new hash map. Right. The next thing is we need a result that we'll be returning. So let's initialize that to 0. Next up, for every single character within S, we need to add a hash map. But just for simplicity's sake, just let's go over all of the letters. We start from A, go all the way to Z, and increment C. Right. So close this off, and then map dot put C and new linked list. Right. Perfect. What do we need to do next? We have to do step 0, which is actually adding all of the words to the hash map. So let's do that. So for string word in words, map dot get word dot character add. So since we're actually looking only at the first character, so you get the first character, which is at 0, and dot offer, since it's a queue, and then you'll offer up the word. Awesome. So we have step 0 ready. Now we have to iterate through all of the letters in the string S. So let's do that. So as a character C in S dot to char array. So the first thing you need to do is actually get all of the words in the queue. So let's do that. Queue string current list or current queue, whatever you want to call it. That would be map dot get C, and then you want to get the size of the queue, because you want to know how many words you're actually iterating through. So let's do that. Queue dot size. Awesome. Right. So for int I is equal to 0, I less than size, increment I. What do we have next? So if you keep incrementing through I, you say let's pop the current word. Current word would be equal to current queue dot poll, and then you check if the current word dot length is equal to 1. That means we've reached the end of the word, and it in fact forms a subsequence. So you increment the count by 1. If not, you add that back. You remove the first letter and you add that back to the map. So map dot get current word dot character at at 1 dot offer. What are we doing? Dot offer. Yeah. So but it would be a substring. So you'll remove the first character and then you would add that back. So substring 1, and it's not S, it's current word dot substring. Let's correct that. Awesome. After the for loop is done, you should have had the result in hand, and we just have to return it. Awesome. So let's compile this and see if it's okay. The first test case is okay. The second one is okay as well. Awesome. So let's talk about the space and the time complexity. The time complexity would be O of W, because you're storing in all of the words that are given in the array, and the time complexity would be O of S plus W, where S is actually the number of the letters in string S, and within that you would also have to go over each and every single word within that particular character. So you would also have to add a linear factor to that. So the time complexity would be a linear time complexity, and the space complexity would be O of W. Awesome. So that's the solution. If you have any questions, please let me know in the comments below. Please don't forget to subscribe. I would really appreciate that, and I'll see you all in the next video. Peace.